All right, welcome to physics 2L class. And today we are going to be doing magnetic field. We're going to be doing magnetic field, and that is the name of the tutorial today. Okay, and my name is Dr. Okay, so suppose that you have a charge. You have a charge Q, and it is mass M, moving with velocity v. What is the magnetic force experienced by that charge? The magnetic force Fb equals to Q V cross product of B, where Q is a charge, scalar quantity, V is the velocity, vector quantity, B is the magnetic field. And because it's a cross product, this is cross product, you can write this expression as Fb equals Q V B sine alpha, if you like. And sine alpha becomes the angle between the velocity and the magnetic field. Okay? And then there is a right-hand rule you can use. This right-hand rule is telling you that if the magnetic field is going this way, and this is the velocity, then this is the what? The force. So this angle is the alpha, which is the angle between the velocity and the field. Okay, so we have that settled. But what if in a case where the charge is experiencing both an electric field and a magnetic field at the same time? Then we need to couple together, we need to add together the superposition of the electric field and the magnetic field. Right. In that case, F, which we call Lorentz, equals to Fe plus Fb. What about a situation where I have the charge moving in a circular path with velocity v, and the magnetic field is perpendicular to this circle? Okay, and the circle is of radius r. What is the relationship in that case? I can conveniently equate the centripetal force to the magnetic force. The magnetic force. And the centripetal force is mv squared over r equals to what? Q. Determinant, because it will be negative. Right? Q VB, say VB0, over what? No, so that's it. So what is R? If I make R a sort of formula, this gives me mv over Q V naught, where one V has cancelled one V. Okay? And I can also write the angular frequency, which is V over R. And that will be what? What is V? You have V, you have R. So if you put this here, this is like what? This is like mv, which would have cancelled that, right? So it's like saying V over mv over QV, so that is Q V naught over N. Right? Is that so? Good. We put V here. This is mv, cancel, you have that. Okay. Now, what about a case where it's not moving in a circle? You have a wire carrying current. If you have a wire and there's current flowing in it and it creates a magnetic field, then we use this formula, I cross integral of the L times B. But if the wire is straight and the magnetic, because the wire could be bent, it could be any shape. But if the wire is straight and the magnetic field is constant, then F becomes I L cross B. You don't need to integrate. This is L, sorry, not E. So it could look like E. You have this. Then there's something also called torque. What is torque? learned about the moment of a force about a point. Moment is the distance times the perpendicular, the distance times the force, right? The same way with this. This is R times F, which is also equal to mu times B, where mu is the magnetic dipole moment, and the formula is mu equals to NIA in the direction of N, where N is if you have multiple coil, maybe a loop, you have many of it. Okay, then you multiply with N. So this is the foundation for today's class. Now let's go to the first question. Suppose that we have this wire, okay, and the current is moving in the vertical y direction, okay, and moving in vertical y direction, and it has a width d, and the magnetic field is in the z direction. This is y, this is x, this is z, and this is b, and it's given as b naught z r. Suppose we have this, and the length of this wire is L. Okay, then can we find the expression for the magnetic field, the expression for the electric field, what is the direction of both fields, and can we also find the electron density? Density is mass over volume. The electron density will therefore be number of electrons over the volume, right? It's simple. Okay, and as these electrons are moving within the wire, the electron, there is a drift velocity, which is like the average velocity of these electrons moving. That average velocity, because the current is in this direction, that Vd, which we call drift velocity, will be in this direction, which is negative y direction. So this will be minus Vdy. Right. Okay, if we have this, let us find the magnetic field. Magnetic field is QB times V, right? Right? So here we have what, and this is drift velocity. So this is Q, drift velocity is Vd in the y direction times B, which is this, V naught ZR. So you need this. Please keep this. I always like to do this. If I call this X, if I call this Y, and I call this Z. X times Y will give me Z. Y times Z will give me X, and it continues like that. X times Y is Z, Y times Z is X, Z times X is Y. The reverse is negative. Z times Y is minus X. X times Z is minus Y. So somebody can say, okay, what if I decide to draw it like this? If I decide to draw it like this, or even decide to draw it like this, as long as just label X, Y, Z, the arrow must go from X to Y, go from Y to Z, and back to X. It's still the same thing. X times Y must give me Z, Y times Z will give me X. Anything against the arrow is negative. Do you get it? So X unit vector times Y unit vector is equal to Z. This times this is this. Then Y unit vector times Z unit vector, this times this, follow the arrow, that is X. And if I follow the arrow, Z times X will give me Y. The reverse must be negative, which is Y cross X must give me negative Z. Z cross Y will give me minus X. X cross Z will give me minus Y. Okay. So this gives me what? This gives me Q, Vd, B naught, Y cross Z is what? Y cross Z is X, right? So this minus is preserved, right? Minus X. Yeah. So what about the Fe? I'm talking about the electric force. This is minus E of X, which is minus E. E here is the potential over D, which is X. and this is minus E V naught D over X. Sorry, let's look at this again. This is Y cross Z. Y cross Z is X. And this is minus. Let's try to get a positive in that direction. VD is negative Y. And magnetic force is Z. So we can now use the Lorentz force, which is Fe plus Fe, and that is equal to 0 because we're doing a superposition of it. So that gives me what? That gives me QVDB naught minus EVD all as X equals to 0. This should give me, this is my X. What is this function in your notes? Please check. Is the function correct? Please check it to your one and tell me the function is correct. Let's check it. Yes, the function is correct. Okay, the mistake is that Q should be minus electron, right? Because we're talking about electron. So that minus 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 is plus. Then we have this. From here, I can say, so let me use E. So this is EVD B naught equals to EV B naught, which is potential, over D. E cancel D. The drift velocity is the potential over D, which is the diameter times this. So I have this. If I have this, my question is I want to find the, so from here, F is positive. That means, and this is negative. So I can populate this side with positive and populate this side with negative. And then, yes, that's right. Now, I want to find the electron density. Current is equal to Qn VdA, which is the charge times the electron density times the drift velocity times the area. And therefore, I can then say that the electron density is equal to I over Q VdA, which is I over Q. Vd is what? Is V naught A over B naught D. So this is the equation for the electron density. Please take a look. Please take a look. And because this is positive, then it moves towards the negative, FB. This is negative, it goes towards the positive, and this is the direction of the electron. Take a look, we'll go to question 2. If you have any question, please ask me. Okay, so let's go to question 2. Let's go to question 2. Question 2 says that if I have a wire, solid wire, this is the Z direction, This is 0, this is L, and it's bent in this direction. This is X, this is boundary A, this is boundary B, in the presence of a magnetic field. And then the current in the wire goes this way, this way, this way, and this way. We want to find the total force experienced in this singular loop. How do we do that? The total force, let's call this 1, let's call this 2, let's call this 3, let's call this 4. And the question says that you should take the magnetic field in Z direction to be B naught A over X, and that is in the Y direction. Okay, so this will be the force experienced in this direction. First 1 plus F, in the second part plus F, in the third part plus F, in the fourth part. Now, I've already learned that the magnetic force experienced by a wire carrying current is equal to what? Is equal to what? Is FB equal to I times integral of the L cross B. I mean something like that, right? This is a scalar quantity. Okay, so let's use this for this question. How do we go? Follow me closely. Please, guys, hello. Follow me. So I want to write F total is equal to, for the first one, which is this. I have I, right? Integral the what? The L here is in the what? Z direction, right? That is the Z arc multiplied by B, which is this, B naught, let me just say B. Here my X is in the boundary of A, right? X is equal to A. Plus 2, which is I, and this 2, this is the part. The part is on the X axis. That is the X arc times B, and B here is a function of X. Okay, plus the third one. The L here is in the Z direction, the Z, negative Z arc, because it's going down, times B. B here has a boundary of B. So X is B, plus the fourth one, I, integral of what? Is going this part. That is integral of the X minus X arc times B as a function of X. So let's write it out. So here we have I integral dz 0 to L, because it's in the Z direction, 0 to L, and then let's bring our B. B is B naught A over X. X is equal to A over A, and then I can multiply this Z arc times the unit vector of the magnetic field. Okay, plus I integral of 2 in this part from A to B. That is from A to B dx. Then I bring my B, which is B naught A over X. This is X arc cross the unit vector of the field again. That is this. And this is X because it's along that path. It doesn't have a boundary there. So I put that plus I integral of 0 to L again dz B A over X. X here is B, and this is minus Z cross Y. Okay, are we following? Plus I integral dx. This is 3. 3 is 0 to L. 4 again is A to B of B A over X, and it's minus X cross Y. Now let's open this. This gives us what? Gives us I. This is B naught. Cancels this, right? And this is now integral of dz. Z cross Y from here. Z cross Y is what? Minus minus x, right? So this is this integral. Let us be straight. Where does it just start? If this is the integral, then we can just write n, right? Because this is just n, right? Integral of z is z, and that is this is n minus x. And this gives us I, right? Integral b not a is a constant, and here you have a to b dx over x, right? Dx over x, x plus y is what? Is z. So if you like, we're going to put z. What is this integral? Dx over x is what? Ln x, right? So this gives me, please follow guys. Hey. If you don't follow, you don't get it. So this is ln x. So if I say ln x, this is a over b. And if I put it inside, that would be what? Ln b over a. And this is in the z direction. Okay? Alright. And this gives me what? I, b naught. This is a over b. And this is l. Just l. And z plus y is minus x. Minus there times this minus is just x. Okay? Then plus, this is I, b naught, a, again, this is a, b, dx over x, x plus y. X plus y is z, and there is a minus there, which makes it minus zi. And dx over x will give me ln x. So this is like saying ln x with the limit of a to b. And if I include that, that becomes ln what? B over a. And now I can conveniently say this cancels this. So I'm left with I write that first. B naught a over b l. This is minus I, b naught l, all as a function of SI. Then I can factor out what is common. I b naught a l is common. I'm left with 1 over b here minus here. I don't have the option how to put this. So if I multiply this by this, a will cancel a, then I reproduce this. And this is x out. This is the total force, the magnetic force, the total magnetic force that is experienced in that wire. It's in the x direction. Tie sharp. Take a look. Let me know if you can move to the next question. Please, go ahead.
Third part of the force.
This part?
No, the third part.
1, 2, 3.
Yeah, third part, fourth part. I want to know the integral, why the integral from 0 to L, but no integral from L to 0.
Thank you. So you can do it. You can either say 0 to L, but if you say 0 to L, then you consider that it is negative. So we have accounted for that by using minus z. If you say L to 0, then you put z. You don't need to put negative. So what we have just done here is this. This is I. This is L to 0 dz b naught a over b z cross y. It can be this L to 0. But if you flip this integral, to be 0 over L, then you must include the negative. You get it now? So then this becomes, let's write it properly. Where's it just? So it's a very good question that is asking. He said, why can't this become I L to 0 dz b naught a over b, then this will be z times 1, because you already accounted that it's already from L to 0, coming from here to this, and it's on z axis. So you can write this, or this integral can be 0 to L dz b naught a over b. In that case, you have to account for the negative here. So we are saying that if you have an integral 0 to x dy, this integral is the same thing as x to 0 dy. Do you see that? If you flip the limit of the integral, you must put the negative. It's a mathematical notation. You get it? Okay. Thank you for asking that question. Okay, next question. Okay, can we go? Right? Next question is, we have such a diagram like this. Not. And side. So we have a rectangular loop here. This is the amplitude, this side into this side. And the field is in this, of course, from north to south, right? You know this. Just like electric line of force goes from positive to negative, magnetic line of force goes from north pole to the south pole. So we know that this is the direction of the magnetic field. Then go this way. There's a force that can be experienced here upward. And more like there is a corresponding downward force here, which is negative. So you have two sides, north and south. That means that the magnetic field basically is equal to magnetic field in the parallel direction plus magnetic field in the perpendicular direction. This symbol means perpendicular, 90 degrees. This means parallel. So if it's in the parallel direction, then the unit vector will be n. In the perpendicular direction, you can use anything, but you can't use x, you can't use y, so let's use t. But the magnetic field in the perpendicular direction is 0, but it has a magnetic field on the horizontal direction. The question we are asked to do is, number one, write the torque in the form of n, the number of this loop, n, a, I, and etc. Already I showed you that the torque is equal to what? R cross F. Did I show this? I think I did, right? And I asked you, is torque a scalar quantity or a vector quantity? When you do a cross product of two vectors, you have a vector. So here, it's more like a wire carrying current, right? More like, I mean, in this loop, right? So if we say that the length to the horizontal side is B and to the vertical is A, then for the top, this is IL cross B. Where L in this direction is B, letter B. So top is equal to R cross IB and B. And remember I said that if it's a cross product, you can as well change this to what? To a sign function because it's a cross product. And this A is like having the radius. But in the vertical direction we have two sides. That's why we have A over 2. And because it's 2, then you have 2 of it. So that 2 cancel 2, and I have I AB B naught sine theta, where this is more like the area, length times breadth. Then this becomes I A B naught sine theta. This is the torque. But for n loop, or n number of turns, torque becomes n I A B naught sine theta. And then if I have this expression, follow me closely. If I have this expression, I can say let the U, not really U, like the mu, which is the magnetic dipole moment, to be N I A in the direction of N. So I can replace my torque to be what? Mu B naught sine theta, and this will reduce to mu cross B. Because this will fall back to this. Please take a look. Okay, and the next question is, the next part of this question. We want to find B. Suppose that N is given as 0.3 SR plus 0.7 Y. You want to find mu. Already we have defined mu as 1A, I, this is not 1, it's a high N high. Then this becomes I, the area is pi R squared, and N, just substitute N, 0.3x plus 0.71. This is the magnetic moment, magnetic dipole moment. Now suppose we also have that B is given by 0.5 Tesla in the x direction or 0.1 Tesla in the y direction. We want to find the torque. We use the formula torque is equal to mu cross B, which is I by R squared 0.3x plus 0.7y plus 0.5x plus 0.1y. I mean, the Tesla is just the unit. You don't need to multiply it with anything, it's just unit. Okay? So if we have this, we can just write our answer. How do you do this? We do this by saying S. So note that in the cross product and dot product, x dot x, unit vector of x dot x is equal to 1. Y dot y is equal to 1. Z dot z equals to 1. But z x dot y equals to 0. When you dot anything against different unit vector is 0, which means y dot z, z dot x, all are equals to 0. Again, if you say x cross x is equal to 0, y cross y equals to 0, z cross itself equals to 0. But if you say s cross y, none of them, then you use that notation. Okay, so here it means that this cross this will be 0, this cross this will be 0. That means I only rely on x cross y and y cross x, because x cross x equals to 0 and y cross y equals to 0. And s cross y is equal to z, and y cross x is equal to minus z. So if we do that properly, we will get that our torque will be equal to minus 0.36i by r squared. Please do that and confirm this. It's just arithmetic, like calculator, roots of this times this, and all that. And in the process, you realize that 0.3 times 0.1 will give you 0.3, right? This is square root. Don't forget this is square root. But if you multiply this with this, you have a bigger number. And it is the negative. So the negative will win over the positive. And that's why eventually it's negative. Okay? Take a look. Ka and sha. She or she. Is it ka and sha or tai sha? Which one is correct? Ka and sha. You have a class now, right?
Yes,
So you can go. I'm going to tell you a short, not like, I made up my mind that each time I come to class, I will tell you something that will improve your life, apart from physics. Like last week, I taught you about the principle of gratitude and some other thing. So today, I found out that in life, there are 4 categories of people in life. Whoever you are, whether you should Joren, you should Megoren, you should Fejoren, you should Megoren, whatever, there are 4 kinds of people. This is the category of the person 1. This is the second guy. This is the third guy. And the 4th guy is like an hybrid, okay? So let me do it again so that this base can contain the 4 guys, okay? This is the first guy. Igore. Yagore. Sangore. Sigore. Okay, this 4th guy is a combination of 3, okay? So, forget about it.